This video will cover how to use the photometry delta f/f function. After displaying the raw data, you can find in the Acquisition Signal tab the photometry delta f/f function. This function is a multi-step operation that assumes you have both calcium-independent and calcium-dependent signals. Note that in the pipeline tools, you can find a general delta f/f function that doesn't assume that there are two inputs. Here, we should select the calcium-dependent dataset where the function will be applied. The smooth signal step removes noise from the data using one of two algorithms. The running average algorithm averages data points within the specified time window. The larger the time window, the more intense the smoothing effect will be. This function is unsuited for non-uniform data where big changes occur frequently, as it is likely to alter not only the noise, but the original signal itself. Alternatively, the low-pass Butterworth filter ensures maximum information is retained below the cutoff frequency, while blocking or attenuating most of the signal above it. The next step, correcting the baseline, removes the slope from both calcium traces. But it shouldn't remove either the calcium peaks nor the motion artifacts, which will be removed in the following step. Here, the larger the lambda, the smoother the baseline will be. The discard signal step removes data outside the range, such as the steep drop in the first few seconds that can distort the fitting algorithm. The last step, fit signals, uses a robust non-negative regression algorithm to detect and remove motion artifacts. This algorithm aligns calcium-independent signals to calcium-dependent ones to check if they are positively correlated. Here, the outliers are the calcium events, while the positively correlated data points are the motion artifacts. Modifying the maximum threshold will adjust the division between the outliers and the inliers by determining how far away from the fitted line the data points can still be considered an inlier. The tips discussed in this video can be quickly accessed at any time using the help icon and then clicking on the element in question. For even more details, you can also check out the GitHub links. Selecting the Apply button will generate the delta f/f output, which is automatically saved in the data processing folder. You are now ready for the next step in your data analysis pipeline, such as finding spikes, which will be covered in the next video. If you have any additional questions, please reach out to us at support@doriclenses.com.